Hey all, and welcome to the last lesson of Calculus 1. We're going to be talking about solving those differential equations that we were looking at with slope fields. Again, we are in 9.3 this time, so make sure that you're going all the way to chapter 9 for the homework, and get yourself ready for notes. So what we're looking at here are what are called separable equations. Now, separable equations have to have three different requirements in order to solve them. So some differential equations just can't be solved, and so that's why we use something like slope fields or other methods that we'll talk about, some of which in Calculus 2, that are going to be really helpful. So the requirements are is that you have to have a term that is a derivative. So dy dx, f prime, y prime, however you're expressing the derivative. There have to be only two variables. Separable equations don't work with 3 or 4 variables. It's got to be just x and y, or sometimes it is like r and h if it's something about volumes of cylinders, things like that. And it's not necessarily 2 letters. Like sometimes you'll have things that are constants. Obviously, if you have a k multiplier in there, something like that, you don't have to worry. The other thing is that they have to be able to be factored. So if you think about from the last lesson, x squared plus y squared can't be a separable equation. You're going to have to use a different method. Now here, let's talk about how to solve these. So find the solution for the equations that satisfy the given initial condition. Now the goal for a separable equation is to separate it into have one variable on one side and one variable on the other. So in that case, we want to say, and that's why I always recommend that you rewrite any derivative that you have as dy dx. Because the first thing that you're going to do is you're going to multiply by that denominator on both sides. That's always going to be your first step with something where you already have the variable, the derivative by itself in this form. So now we have dy is equal to y times cosine of x all over 1 plus y squared dx. And what this now tells us is that we want, this is going to be the y side, and this is going to be the x side. So I want to keep these terms together because they are the x terms, and that means I'm going to divide by the others, and I'm going to end up with 1 plus y squared over y dy is equal to cosine of x dx. So now I have my two sides of my equation with my separate variables, my y's and my x's. Now, here's the step where you can actually do some solving. Is what you're going to do is you're going to take the integral of both sides. So you're going to go like this, and if you do it to both sides of the equation, it's just fine. And you're going to do some simplifying. Now, what I'm going to do here for the y side is I am going to separate that equation 1 over y plus y, so I can take the two terms separately. And then the integral of cosine of x is one of our nice straightforward trig ones. Whoop. So then the integral of 1 over y is the ln of y plus the integral of y, which would be 1 half y squared is equal to sine of x plus c. You only need plus c on one side, right? Because if there's a plus c here and a plus c here, you could just subtract that over and it creates a new constant. It's just easier than keeping track of a bunch. So here's our function, and then it gives us our initial condition, which says that y of 0 is equal to 1. So that means that x is equal to 0, y is equal to 1, and we can plug that in to find our c value. So in order to find c, I'm going to say, well, the ln of 1 plus 1 half times 1 squared is equal to sine of 0 plus c. Ln of 1 is 0. this is plus 1/2 is equal to sine of 0 plus c. So 1/2 is equal to c. And the equation would be ln of the absolute value of y plus 1/2 y squared is equal to sine of x plus 1/2. Now, this one you can't solve for y by itself, so I'm just going to leave it like this, though there are going to be some that you can solve for y by itself. Now, when we look at number 2, this one's a little bit harder because we have our added terms, so we're going to have to do some factoring, and we are going to want to rewrite our y prime. So the first thing that we're going to do is we want to set it up the way that we saw it before. So we want to rewrite this as dy dx and solve for the derivative. So what do I mean by that? What I mean is I want to get y prime by itself. So y prime is equal to y squared minus y divided by x. So I've solved for it by itself, and then I'm going to rewrite dy dx here. Now that it looks similar to our last one, I am going to do the same first step, multiply by the dx, and I'm going to end up with dy is equal to y squared minus y over x dx. Again, I want an x side and a y side, so I'm going to keep these together, and I'm going to divide by y squared minus y. So dy over y squared minus y is equal to 1 over x dx. And I'm just going to separate the y out so that the dy comes later, so it looks more like a standard integral. And we end up with 1 over y squared minus y is equal to 1 over x dx. And then we can integrate both sides. Now, this is unfortunately, and I tried to avoid this in your homework, this is a integral method that you haven't actually seen before, and I should have planned a little bit better ahead before I started recording this whole video. But well, yeah, you live, you learn, distance learning, what a time. This is called partial fractions, this method. If you're interested in it, please do look at it, but it's something that we will cover when we are going into our Calc 2 materials. But what you do end up with is that 1 over y squared minus y as a fraction can be rewritten as negative 1 over y plus 1 over y minus 1 dy, and that's equal to the integral of 1 over x dx. And if you just want to check this out, you can do some good algebra there if you're interested in looking at that, or you can trust me, depending on how you feel about that. Now, the integrals for both of these, this would be negative ln of y plus ln of y minus 1 is equal to ln of x plus c. Now, this is definitely one where I can solve for the y by itself because they're all the same type of functions versus here where we had natural log and a polynomial and trig. Here, they're all natural logs. We can simplify this. I'm going to start by saying that on this side we have natural log of y minus 1 over y, because then subtracting a log turns into division, and adding a plus c, this is going to become, we can just leave that out there, so we can just write this as ln of x plus c. And here's the part where you get a little tricky when we go to raise everything to the e power. Cancels out completely here. We get y minus 1 over y is equal to, and this doesn't cancel out completely because this is e to the ln of x here, but then the plus c is the same as e to the c like this. So then this will cancel out, and e to the c is just equal to another bigger constant, but it's being multiplied now. So the way you'll often see this rewritten is c times x, like so. Now on this side, I'm going to simplify this to 1 minus 1 over y. And I'm going to solve for y by itself. So that would give me 1 minus cx is equal to 1 over y. And y by itself is 1 over 1 minus cx. And if I want to solve for c, I'm going to use that initial condition, which says that 1 over 1 minus c times 1 for our x value is equal to -1, which tells us 1 is equal to c minus 1. So c is equal to 2. So for my final answer, I'm just going to take that c value and I'm going to replace it with a 2, and y is equal to 1 over 1 minus 2x. If you have questions, please let me know and I'd be happy to answer them. And make sure that you fill out the survey, and I will let you know the results on Friday. So please make sure that you fill that in so that you are able to attend the meeting and I know what time everyone is available. Talk to you later.